Yeah. Hi everyone. Now we are going to look at the concept of perceptron in machine learning. First, let me explain you the fundamentals of perceptron in machine learning, which is a very finite concept when you learn deep learning in artificial intelligence. So first we look at introduction to perceptrons and their significance in machine learning. So first we understand the concept of perceptrons. So perceptrons in machine learning were the smallest form of artificial neurons. So perceptron is nothing but an artificial neuron which is simplest possible neural network. So this neural network are the building blocks of machine learning. So the perceptrons are the simplest form of artificial neurons used in machine learning for binary classification. So originally, Perceptron was designed to take a number of binary inputs and to produce one number of output that may be true or false, or yes or no, or either 0 or 1. So the idea was to use different weights to represent the importance of each input so that inputs process much values inside it and generate an output for us that may be the decision based on yes or no, true or false, or 0 and 1. So the role of perceptron in machine learning is just to make the complex neural network easier, and it helps us and serves as a building block of many multi-layered learnings. So these major applications of perceptron is basically used in image classification since it was done by the neural network of machine learning. And when we talk about the historical context of perceptrons in machine learning, so the first perceptron was first discovered by the psychologist named Frank Rosenblatt in the year of 1922. So he was a psychologist, American psychologist in the field of artificial intelligence. In 1957, he started something really big. He invented a perceptron program on an IBM 704 computer at Aeronautical Laboratory. Scientist has discovered the brain cells called neurons receive input from our senses by essential signals. So that neurons, which we call it as the brain cells, then again use electrical signals to store the information and make decisions based on the previous input. So that Frank had an idea that perceptron could simulate brain principles, which we actually know that the neural network is more similar to artificial neural network. So the influence figures in perceptron research is that prominent researchers has contributed to understand and improvements of perceptron models throughout the history. It's not the Frank who initiated it, but there were many people who involved and made it to a final decision. And if you look at the basic architecture of a perceptron model, as I told you initially, that it very similar to artificial neurons. So the structure of single layer perceptron is very simple, where we contain some input nodes and we have weights and we have an activation function that produce a better output, and we have a training process and then some limitations. We'll look at them in the future. And if you look at the perceptron performance over the time, so understanding the performance is very important in the historical context, and we need to look at the basic architecture and its uses in the applications of artificial intelligence and the future of perceptron. You can see the percentage over here so that you get an overview of how performance has been changed over the time. And now let's look at the applications and limitations. So coming to real world applications, as I told you, it majorly used in image classification since the image classification is under the artificial neural network, which is a deep learning concept. So all the influence of the perceptron is completely based upon the projects that we work under deep learning and artificial neural networks, and it makes data driven decisions easier when compared to the previous projects we have in life. and some challenges that has been faced by the perceptron in complex data. It complex data can be represented in terms of big data. So limitations in handling non-linear data. What do you mean by non-linear data? So everywhere you find this disadvantage in whatever the concept in machine learning, there will be an advancement just because the data is non-linear, which actually means that it is not proper, where you cannot separate the data. Like for example, I have taken a bucket full of water and there is some oil in it. So you can see that the separation of oil with the water is more familiar, so that it is linearly separable. But some data sets which data is not complex, so it is not linearly separable, and there were large amount of limitations here. You can look into them. And the future prospects of perceptrons technology in artificial intelligence is very important, since we are living in a society where artificial intelligence is boom. So learning perceptron, understanding the concept of perceptron is very important in terms of artificial intelligence and machine learning. So effectiveness of perceptrons in the real world application is seen here, like with some examples. And so this is a very small introduction about the fundamentals of perceptron in machine learning. So now I am going to take you, yeah. Now look at basic summary of what we have discussed till now. Is the, as I told, perceptron is an artificial neuron, and it is the simplest possible neural network, as the neural network is the building blocks of machine learning. As we have seen the history of perceptron before, as I told you, the original perceptron was designed to take a binary input and to produce a binary output. How do the output is generated? The output is generated by adding some weight and comparing that to a threshold value. How do we do that? We look that in the future. Meanwhile, let me tell you a simple example. Imagine a perceptron as mentioned here in your brain. So the perceptron tries to decide whether you should go for a concert or not. So some criteria or else some constraints that matters here is artist is good, or the weather is good, or your friend will be accompanying you or not, or the food is served at the venue, or alcohol is served. For every criteria I have taken 1 or 0 or 1 input value, and I am adding some weight to it. I think I am clear till now. I am taking a criteria and an input value and some weight to it. Now coming to the perceptron algorithm, let's look at this very clearly. So this was suggested by the prank, which first set a threshold value, set a value. I My threshold value is 1.5. So multiply all inputs with its weight. How do we do that? Multiply all inputs with its weight. For x1 is my input and the weight that I have taken is 1, and my weight, x1 is the value, weight something that I have taken can be calculated as input into weight. So what was the input is 1 and weight is 0.7. So what was the value of x1 is 0.7. In the same way, perform it for all the inputs. Take an input, multiply it with weight. So that will be the weight. So next, sum all the results that you get 0.70, all these results. So then you will get a value which we call it as the weighted sum. Compare this weighted sum with your threshold value. My initial threshold value is 1.5. So it returns true if your sum is greater than 1.5. You will go to the concert. So what will be my output? My output is 1.6, which is far greater than 1.5. So I can decide with this criteria input and weight, the person will go to the concert. So if note, there is a note here, if the weather weight is 0.6 for you, it might be different for someone else. The higher weight means that the weather is more important to them. So that's where it varies. So let us look at a very simple example where we'll be looking a code on perceptrons. How do that perceptron really work in physical world? Let me take a threshold value as we have seen before, 1.5. I've taken one input and some weight to it. Now what do we do, guys? I just multiply this input with weight. I'll store it in the sum. So I'll check that if the sum is 1.5, I am allowed to go. If not, no, I am not allowed. So this is perceptron in artificial intelligence. As we've discussed, it is a part of artificial neuron where this artificial neuron is taken from biological neuron, plays a crucial role in artificial intelligence. So it consists of 7 methods where we have already seen. First, take one input. It either be 10101 or anything, and take some node values which is 0 and 1, and now take some node weight can be anything, as we have taken the above example as 0. 0.7, 0. 0.6, 0.5 and so on. And next we have summation. What do you mean by summation, guys? Summation is nothing but you sum the value which comes from the multiplication of input and the weight, and then compare it with threshold. And now this comparing of threshold, we call it as activation function in general terms, but in programming we'll see how does it actually work. So if the sum is greater than threshold, it's true that you are going on a positive note. If not, no, the something that you are doing is not correct and which is not true. So perceptron defines the first step of neural network. As I told you, they were placed upon the artificial neuron, which is the input layer of neural network. So I hope that you got a very clear understanding after seeing an example and algorithm of what is perceptrons in machine learning. And now let's look at code. Yeah. So I have taken a very sample example of perceptron code where I already mentioned above. Everywhere when you work on perceptrons, it's nothing but you have an input, you have a weight, and multiply that input to the weight and add those all sums and compare the sum with the threshold value. If you look at the code, first something that I have did is import necessary libraries. You import some libraries. Here I imported numpy and matplotlib, which numpy helps to handle the array and math operations, and matplotlib is used for visualizing if needed. Not used here but useful in general. So the second step is input features and labels. So here X is a 2D array with input pairs and Y is an expected output label for each input. This example represents the AND gate. How do we generalize that? It's very simple. In AND, input 1 is 0 and input 2 is 0. What is 0 and 0? Gives you 0. And 0 and 1 gives you 0. And 1 and 0 gives you 0. And when there is 1 and 1, it will give you the value of 1. So that's how my expected output has been taken. The third step is initialize the weights and other variables. So here we have taken a weight of 0 of 0, one weight for each input. And next, bias obviously starts from 0, and learning rate controls how fast the model learns, and small values like 0.1. So a coach is the number of times your model looks at the whole data set, like 10 rounds for practice. It's how many times that whether your code is going to loop. So it indicates that. So the first line indicates the number of times that your loop is going to do. It's actually 10 times as we have mentioned above. And the inner loop will tell you it checks each input one by one. And here as we discussed, we calculate the weighted sum along with the bias, and if the total is greater than or equal to 0.5, so we say that output is 1, else the output is 0. So if the prediction is wrong, error will be no 0. So again you adjust the weight, and bias to reduce the error for the next time in this line of code. So this is how you will get. In the first loop there were no errors, there were error at 1 1, and then you adjusted the bias and the weight. So that's how you do the program. And the final step is nothing but testing and trained perceptron. So now we check how well the perceptron is learned. So it will print the predicted value for each input. So here the weight defines learn how important each output is. So bias helps to shift the decision boundary, and learning rate helps to decide how fast the model learn. So this was the final output. So Perceptron is a very fundamental concept. I'll be sharing this Google Colab link with you. So go through it and go through along the PPT I've explained above with the content that I've shown you. Thank you so much.